answer. So as we go through this, the first things we'll talk about here inside of your body are the ways that your body tells its cells to stop dividing. It's the reason why, when you scratch yourself, your skin knows to grow back together, but it doesn't begin growing over itself. It doesn't wrap around there. So it's the reason, it's two ways that your body knows when to stop growing cells. And the first way that I'll have you guys get down, and remember, you're writing what it means, not what it says, if that makes sense. The first way we'll talk about is contact inhibition. So sometimes it helps if you listen to what I say and then write down what you think is important. And contact inhibition is this. Your cells on the outside of it, around its cell membrane, has a chemical. And when that chemical touches other cells, it tells them not to divide. So that means that when cells touch other cells, they know, because of that chemical, I shouldn't divide right now. That's how your body knows when to start regrowing cells when you scratch yourself, because all of a sudden your skin that was scratched off isn't touching other skin anymore. So it knows I need to grow more skin. So it grows more skin to cover up that spot. And as soon as they touch, the skin stops growing because it's got those chemicals on the outside. And when they touch, that chemical tells it, hey, you're good to go. Hunter?
Isn't there, even when you get a cut, aren't your cells touching other cells, cells inside of you?
So if you cut your skin, right, literally your skin, one edge of your skin is just touching air. And that edge continues to make new cells until they come in contact with each other, and then it's over, then it's done. And that's called contact inhibition. That happens with your cells in your body. When they touch each other, they know to stop dividing. And that's true for cells all the way in your body. Right? Cells live and die. They go through a course of their life where they live and die naturally. And if one of your cells has a neighboring cell that dies, it realizes, let's make a new one of me to cover in that spot. It fills up that spot. Yeah, you're losing lots of cells when you do that. So if you itch continually, you start to bleed, you're getting through your cells, right? So, yes, that's the idea behind it. Hey, the other way that cells do this is with a chemical on the inside called a cyclin. And I'll talk to you about what those do here. So cyclins are proteins on the inside of the cell that release, that pause the process of cell division. So it's like a little internal thing that says, hey, wait a minute, we're going to check stuff out, and then it goes on. And we'll talk about the two spots where those come up and why they happen. So cyclins are released in a couple of places during the cell cycle. So you remember the whole cell cycle, right? There's G1, then there's S, G2, and then the mitosis phase, prophase, metaphase, anaphase, telophase. They get released, where we're concerned, in two spots. Cyclins, these things are released during the S stage, or S phase. Do you remember what the S stood for in S phase? No problem. This stood for synthesis. And when they synthesized, they were synthesizing their DNA. So they were making a copy of their DNA. So the first spots we're concerned with that cyclins are released are in the S phase, where it makes a copy of its DNA. And what happens is that they are released at the end of it, the conclusion of the S phase, so that the cell can check the copy it made. It just copied trillions, maybe more than trillions, of pairs of DNA, like all those letters, and it has a chemical that's released that says, hey, let's stop for a second here and make sure everything's all right. So it's released at the end of the S phase so it can go through and proofread the copies it just made. So to proofread, proofreads the DNA. Makes a copy of DNA, says, let's stop, let's take a look, make sure is everything all right. If everything's good, the cyclin is out of the system, the cell goes on to the next stage, everything goes normally. Sometimes, though, in that stage, it'll notice that it made an error as it was doing its thing. So it reads through there and realizes, oh, hey, I messed up the DNA code right here, and then it's got two options. Option one, it can fix it, in which case it'll go back and fix the little error that it made. Option two, it reads it and says, I don't know, this is wrong, this doesn't work, I can't fix it. So if it finds an error, So that it can't fix, it goes through this process called apoptosis, which is cell death. It kills the cell. The cell commits suicide is what happens. The cell realizes, like, there is something wrong with me. I cannot fix it. I can't pass this on to other cells because they'll be damaged. So the cell has an internal mechanism that says, like, I can't pass this on. So it recognizes it and ends it. To make sure you know is that apoptosis is like the cell killing itself. That's a key word. The second time this happens, there are two stages we're concerned about, like I said, is at the end. So there's one spot right there. The next spot we're concerned about is at the end of the mitosis phase. It releases at the end again, so it releases chemicals again, and at this stage, the cells check themselves. They go through like a self-diagnostic. Do I have all the things I need? Am I the right size? Am I going to be doing the right thing? And if the cell is not, it goes through this process. If the cell recognizes, like, hey, I am not the way I should be, the cell goes, I'm out of here. It fixes itself by deleting itself, basically. And that's what those two pauses do. So your body has pauses built in intentionally for your cell to check and make sure that it is good and ready to do its next thing. When stuff goes wrong with those things, your body loses its ability to respond to those things. That's when you get stuff like cancer. So next, am I okay to roll this one over? Okay. The next one that's going to pop up is just a picture of like how contact inhibition works. So these are supposed to be in like stages, like 1, 2, 3, 4, 5. So here would be just human skin cells cultured on a plate, like a petri dish. And over time, they grow to fill up the whole plate. They don't grow over it. They don't grow over each other. They just form one like thin layer on the plate. Then the experiment was, once the plate was full, they took a scraper and just ran it through the middle, cleared off all the cells in there. And they discovered that the cells grew back together, but no more. They grew back together, but didn't continue growing. And that's how they figured out that there was something on the edge of these cells, on the cell membrane, that allowed them to stop the other cells around them from growing. And some plants kind of do the same thing. I forget what the name of the plant is, but there are some plants that release like chemicals into the ground around them, so they stop other plants around them from competing with them. So only they can grow there, because only they can release that chemical or deal with that chemical. So we've got what happens when stuff is uncontrolled, when that growth of cells, when it goes through the growth and then the division stage uncontrolled, it is called, as it says, cancer. And cancer is just this. This is the definition of it. It is a disorder in your cell. It begins as a single cell in which cells lose their ability to control cell division. So write this in a shorter way, but cancer is when cells lose their ability to stop dividing. They don't respond to the internal thing like the cyclins anymore. They don't respond to contact inhibition anymore. They just grow. And it is from a mutation, like Houston brought up earlier, that cells that this happens to, it begins as a mutation in their DNA. So you can't catch it, as you guys probably are well aware. Somebody with cancer can't sneeze on you and give you cancer or something like that. You can get a blood transfusion from someone with cancer and you don't get cancer from that. It's not transmissible that way. All it is think about all the trillions of cells that you've got all throughout your body. All cancer is one of those cells loses its ability to stop growing and dividing. That's all it is. One of those trillions of cells loses that, and then it happens. It grows uncontrolled. It grows through stuff, and as it grows through stuff, it can like pinch off arteries and veins, which supply blood to things, which is why people start to die from cancer. They lose function of those organs because it takes over the space there and starts cutting off the nutrients they need, things like that. And cancer cells are cells that just don't respond to the normal signals of cell division, so they can't respond to it. They're exposed to the chemical, but it doesn't work on them. Yeah, it can't respond to those cyclins that we talked about, those events that try and slow it down. And because of that, because cancer is like a problem with mitosis, where the cell just divides uncontrollably, what they do to treat it, one of the ways they treat it is with chemotherapy. If you guys have ever seen someone that's gone through chemotherapy, it's like heartbreaking. It's incredibly painful. They lose their hair. They have open sores a lot of times. And that's because chemotherapy actually prevents mitosis from happening. So cells still grow, but once they get to that point we talked about where they're so big, a mechanism in them triggers them to divide, the chemicals that you get from chemotherapy prevent that division from occurring. So those cells are never able to divide. So when you get a cut or a wound when you're on chemotherapy, it can't heal because those cells can't divide to close up that wound. And the idea with chemotherapy is to get you as close to death as they possibly can. If you've ever seen somebody go through it, it literally kills them a little bit at a day. They get you very, very close to being so sick from this toxic stuff that you're about ready to die. And then they take you off of it and your body recovers. Your cells go through their division like they're supposed to, and then they put you back on it. And their hope is that since cancer cells grow and divide so rapidly, that they're causing more damage to the cancer cells and killing those more than they're hurting you. So that's the approach of chemotherapy, is they're hurting the whole you, but they're hoping they're hurting the cancer cells more than you in their attempt to try and kill them. Houston? Are some examples of cancer that you might have on your skin. So I've got lots of moles. All you guys ever get to see me is my hands or my face, but I've got moles that cover my arms, and they're just dark freckles. I don't know if you can see them or not, but I've got moles on me, little dark spots on my skin. Most of those are nothing. Most of those are not a big deal. But sometimes those things can become a big deal. Things on the right are ones that are likely, like carcinoma or skin cancer, things on the right. So things you want to look for are asymmetrical shapes, shapes that aren't like normal. You know what symmetry is, they're not symmetrical. They aren't the same on both sides. If you've got moles that are not symmetrical, that is sometimes a sign. If you've got moles that have irregular edges, see how this mole is pretty round and has defined edges, and the same thing here. This one's got kind of cauliflower looking edges or broccoli looking edges. That's a sign. If you've got moles and on those moles they change colors, the mole itself has different colors on it, light on one side, dark on another side, that's a sign. And then diameter, how big they are. The bigger it is, the more likely it is to be in this carcinoma category. So one thing I do, because I've got moles on me, is I see a dermatologist every so often, and he just checks the moles. Everything looks fine, you're still good. Because if you've got those things, you should get those checked, because they can go from being good to being bad like that. Or if you see some on your body that are growing, that's a sign. That's a sign you to go see somebody. Because you wouldn't think so, but these can kill you. Skin cancer will get you. And skin cancer is caused, what's the main cause of skin cancer? Yeah, you're exposed too long for the sun. So you lead your healthy, active lifestyle. You're out doing your stuff all your life. You've always got a tan because you're always outside doing your thing. But all that exposure to the ultraviolet light from the sun actually damages your DNA and causes mutations, which cause cancer. So if you are a runner who's outside all the time, running in the summer without a shirt on or with short sleeves or whatever, wear sunscreen. It prevents this stuff from happening. If you're an athlete that's out in the sun or just someone who's out in the sun all the time, put on sunscreen. Even every day on your face, if you put on lotion that has sunscreen, it decreases the likelihood that you'll get this stuff. Houston and then Sheridan. So on the left side is like it says, normal lung tissue, and a lung inflates to give you your air. On this side is one that's obviously deflated, but with cancer, it grows into your lung tissue, and it crowds out the other lung tissue that's in there, and the result is that your lung can't do its thing. It can't expand and contract like it's supposed to. So a lot of times people that have lung cancer are on supplemental oxygen, so you see them with the oxygen mask, and that's because the area of their lung has decreased, so they need more concentrated oxygen to breathe in so that their lung can utilize it. So it kind of shuts down your lung. That's how my grandma's cancer started, was in her lung from smoking, and it spread to her body. There's pretty much, it's not a one-to-one relationship, but it's pretty darn close. If you really, 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 really want to get cancer, just smoke. That's all it takes. If your goal in life is to have cancer, smoke cigarettes. You will almost assuredly get lung cancer, and it's almost a guarantee. There are other things that can cause cancer too, obviously, but any kind of smoke, like if you're constantly exposed to smoke, you're going to be very likely to have lung cancer. It's just a fact. Other things, this group of chemicals are called carcinogens. They're the things that give you cancer. You can get them from your food. You can get them from breathing in the air. Basically, like, cancer's all around you. It's just a matter of time. Like we said, 1 and 2. Keelan? Yeah, that's equally as bad, right? And that was a drag for a long time. Like, waitresses were getting lung cancer and they never smoked, but all their patrons in the bar were smoking, so they were getting it even though they never smoked in their life. And the younger you start this stuff, the more hazardous it is for you while your stuff is still developing. So if you're smoking now, and it doesn't matter if it's like tobacco or other non-tobacco products that you're smoking, the impact is the same and more dramatic when you're young. Some of my hippie friends are like, no, man, you can smoke marijuana and it's okay for you. But the fact is, like, the smoke is really bad for you. And it doesn't matter if you're smoking marijuana or you're smoking cigarettes and they're filtered or whatever. It's the chemicals in that smoke that attach to your lungs and cause the mutations. It doesn't matter if your stuff is organic or not. It's going to get you. Houston? With 2 types of tumors that are there, and one are called benign tumors. So this is going to say one thing, but I'm going to have you write something that's slightly different. Benign tumors are cells that are cancerous cells, but they're growing inside of a membrane. So it's like this thing growing inside of a plastic bag inside of you. It's not growing into other stuff. It's pushing other stuff out of the way. So they are cells that are inside of you that are cancerous, but they're not taking over this. They're not like growing into other organs. They're pushing stuff out of the way, moving organs around. And one was in the news recently, and that was a guy, all these weird stories come out of Florida, but of course he was from Florida. He was about a 500-pounder, and he was way overweight, and he kept telling his doctor, like, this is not, like, there's something inside of me. And his doctor kept saying, no, you're just really, really overweight. That's just, you eat too much. And finally the guy said, listen, you need to get this out of me. So he went to a different doctor, and they took out a 120-something pound benign tumor inside of him. So they took out like a high school freshman from his stomach. And think about that. That's huge. So that's a benign tumor. It is not something that will kill you if treated. Right? Benign tumors. With your focus here, please. Benign tumors are not the ones that'll kill you. You'll notice them. You can get them treated and that. The ones that'll get you are these ones. These are called malignant tumors. Malignant tumors are cancer cells that grow into and through other organs. So instead of just like pushing stuff out of the way, like a malignant or a benign tumor, right? If you could take your fist and like push it into your stomach or something, it doesn't grow into stuff. It just moves stuff out of the way. A malignant tumor is one that would be like putting your fingers inside of you and like going into your organs and things like that. A benign tumor pushes stuff out of the way. A malignant tumor invades other cells in your body. It like separates stuff. It can grow into your pancreas and into your liver and into your stomach.
So like when you have a tumor and it's, no one they take it out, but they still make the person go through, why do they do that even though they take it out?
Because you don't get 100% of it. You get like, and then there are cells that break off and float through your body from it that need to be like wiped out so it doesn't spring up somewhere else. So malignant tumors often do this. They metastasize. If you've heard that term before, that means that your cancer may start in your lungs, but some cells, like Hunter was just talking about, break off from it and begin growing in other places. So you may start with lung cancer, which is what my grandma had, but it spreads to other places. It goes through your blood and through your lymph system. So she started with lung cancer and then had brain cancer and like esophagus and whatever, liver cancer. So she ended up with it everywhere. But they traced it back to just her lungs. It started in her lungs and spread out from there. And that's called metastasis. If your cancer metastasizes, your likelihood of survival is pretty low. You don't want your cancer to metastasize. You want it to just be in one spot.